Woohoo! We are live, and this is the X method, another way to factor trinomials. And I know you're all asking yourselves, why are we even here? And the answer is, I don't know. But as long as you're watching the video, I will do my best to explain what the X method is. So the first thing to take a look at, you may want to screenshot this. This is the method of using the X method. Now, some of you might be looking at that going, oh man, only Professor X could possibly understand this. And the answer is that is very possible. It could be that this card is only helpful for me, but this is what I use to help me remember the steps. This particular method for factoring trinomials is, once you get practice with it, it is faster than trial and error. And for some people, it's faster than the AC method. I'll remind you the AC method. Let's see if I can scooch this up. Can I get these both on screen at the same time? And we're going to refer back to it. The AC method is very similar. This is a method of writing down the AC method in a slightly different way. These are basically the same way of doing this factoring. However, this is going to involve a lot of memorization. You're going to have to remember the different steps. Trial and error is slow and steady. You just keep banging away at the trinomial till it agrees to factor. So it's just wearing down your opponent as opposed to coming in and being all pew, 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 and then being done. So it's up to you which method you'd like to use, but I'm going to do my best to try to explain how to use this method. It's called the X method because, one, the X method is awesome, and also because we're going to draw an X. But before we draw an X, we need a trinomial. So you are just having just a mild-mannered day in your town when all of a sudden, oh my goodness, it's a trinomial. Ah! Call the X method team. And they swoop in. Pew, pew, pew. Okay, so first thing we need is we need a trinomial. So the trinomials we've been working with generally fall into the category of polynomials, 3 terms, hence trinomial, ax squared plus bx plus c. You do not have to use x as your variable. You could use pretty much anything you want. Using a, b, or c as your variable would be very confusing, and I would encourage you not to do it, but you could have T's, you can have D's, you can have happy faces, really whatever you can draw, you do you. So I've got ax squared plus bx plus c. Notice it's in descending order. This is key. Your x squared has to come first, then your x, then your constant. So in our case, for this particular problem, we've got 3x squared plus 5x plus 2. So the first step, after we've identified that we do have a trinomial and we've put it in descending order, so the x's get smaller as we go along. The x's themselves don't get smaller, of course. What I mean is the exponents get smaller. See how it's all x's, the exponents? Ooh, the X method, the exponents. Okay, so I'm going to use some colors so that they match my handy dandy card here. So I'm going to identify A, B, and C. And these are also designed so they work. So I feel like I could be a Tupperware salesman. All of the cards are designed to work together. You can reverse them. You can use each of the lids fits on each of the cards. Okay, so we've got 3x squared, so that tells us that a is 3. We've got 5x, so that tells us that b is 5. And, ooh, I forgot my purple over here, but this little guy that doesn't have an x at all, or you could consider it x to the 0th power, this one is called the constant coefficient, or just the constant, and that's 2. So it does not change because, there's no x, there's no variable there. So it is the constant. Okay, so once we've identified A, B, and C, then we're going to draw our X. Woohoo. And what I'm going to do is I am going, I want to, not that I have drawn this X before, or not that I've actually recorded this video like 100 times and keep finding things that I want to change, so I have to start over again. But let's go ahead and just use a color there rather than dotted lines. So over here, I'm going to give you the formula, and over here, I'm going to use the application, right? Ooh, look at me using sides. I know, this is very exciting. This is technology. Another way to talk about this, if you want to be fancy and use education speak, this is a graphic organizer for your formula. It's very exciting. To begin with, I always feel like I should say the Marleys were dead. And then I give away the fact that my favorite version of A Christmas Carol is the Muppet Christmas Carol, because there are two of them. Okay, so A times C goes up top. Where can I put this? You know what? Let me. No, you can't see it there. Can you see it there? You can see it there. So up in the top, I'm going to write A times C, and then I'm going to write this little dot there, which you don't know why yet, but you may suspect. So it'll be like an exciting mystery. And then down here, I'm going to write a B with a plus. Again, ooh, what is this magical? Totally, we're summoning trinomial demons. That's what we're doing right now. Don't tell your parents. Okay, so I've got A times C on top and B on the bottom. Now, in a perfect world, once you practice this method a lot, you will stop thinking about the A's and the C's and the B's, and you'll do a straight translation from the numbers into the X. So let's talk about over here in the application world. We'll draw ourselves an X, and we'll think to ourselves, okay, we want, let's see, this is B. There we go. Here's A. And here's C. C is kind of like Pluto. There isn't a lot of room left for it. Maybe it kind of falls off the list. But it is important. Oh, I keep forgetting it over here. It is like Pluto. There we go. It's just very small. Now, when you look at this method, you're going to see, so I'm going to take the outside numbers, and I'm going to multiply them together. So I'm going to take this 3 and this 2 right there. And then B is 5, so it goes down here. And then the other part of this that I learned from a student is you write multiplication here and you write plus here. Now, is it possible you have a different way of doing this method? Absolutely. The X method is all about mutations. It is all about embracing diversity. So if there's a different way that you do this that works for you, that's awesome. Yay, you. You do you. Rock on with your bad self. I do it this way because this helps me because my memory is a little bit, I mean, you know, like if I were young in the 1400s, that makes me about 600 years old. So my memory is going. Yes, it is, definitely. It never really was there. Okay, so I've got 3 times 2 up top and 5 in the bottom with these inexplicable plus, multiplication and plus. And then we've got a couple of things which are true. What is true? Well, we're going to go ahead and set up these formulas. A times C equals a question mark times a question mark. And B equals a question mark plus a question mark. And again, I know I mentioned it right at the beginning, but let me remind you that we have got exactly the same setup. A times C equals something times something, and B equals something plus something. This is what we've got right here. So let me look again. A is pink. So I've got pink over here. C is purple. Purple right there. B is green. Green right here. And then we've got, and this is very mysterious. Ooh, it's the spooky part of the problem. We've got the mystery numbers. Dun, dun, dun. And the mystery numbers are actually going to be the key to solving this problem. This is the part you have to figure out. So we've got basically that set up. And I'm going to remember that A times C equals this times this guy. And then b equals this plus this. So let's go in and look at this. So the a times the c, the top of the x, 3 times 2, which you could have written as 6, is equal to the product of the two mystery numbers. And 5, the b, is equal to the sum of the two mystery numbers. And so the question is, how do you remember that this one's the product and this one's the sum? Well, you've got multiplication up top. That reminds you it's multiplication here. And you've got a plus down here. That's how you remember that. So how do you remember that multiplication is on top? Well, let's be honest. If you've been watching any of my videos, you know that multiplication loves you and addition hates you with a passion. It's like the fiery pit of hell kind of passion of hate. Addition is probably the worst thing ever. And if you disagree with me, let's talk about fractions. So you shouldn't disagree with the math teacher, though. Just don't do it. They're pretty much always right. Even when we're right, even when we're wrong, we probably could come up with a way that we're right. So just, it's not worth it. So, and how do you remember that A, C goes on top and B goes on the bottom? Well, B goes on the bottom, right? So these are the little memory keys to remembering this. What else should we do? Well, we've got these two spaces over here. And again, this is different depending on your type of X method. But what I learned is that we put the question mark over A over here and the question mark over A over here. So what the heck does that mean, question mark over A and question mark over A? Well, so what we're going to do is we're going to have to come up with these two question mark numbers because we've got a pattern that we can solve. This little puzzle. So I need to find two numbers so that when you multiply them, you get the same answer as 3 times 2. And when you add them, you get 5. So let's talk about that. Let me scooch this up just a little bit. So we need and remember that mathematicians say such that because we're all very, very old, and that's the way people used to talk in oldie timies. So we need to find two numbers so that or such that 6 equals the product of those two numbers, and 5 equals the sum of those two numbers. What two numbers multiply to give us 6 but add to give us 5? And so I would claim that you could think about it. You could say, okay, so 6 could be 6 times 1. 6 plus 1 is 7. Nope, that didn't work. 6 could also be 3 times 2. 3 plus 2. That works. Yay, look at that. We got it. I know I put it in the corner. I didn't want to go to the next page yet. Okay, so our two magic numbers are 3 and 2. Now, could you have gotten 2 and 3? Absolutely. You can get them in either order. Does not matter. 3 and 2 are our two numbers. So now what do we do with those numbers? Well, in the AC method, once you find the numbers, remember what you do. You take the two numbers and you split up the middle term, and then you factor the two different sides using factoring by grouping. We're going to use a slightly different method at this point. We're going to take these two numbers. We're going to take the 3, which I found here, and I'm going to write it above my A. And here I'm going to take the 2, which is my other secret number, and write it above A. Let's look. I know at this point people are like, wait, what's going on? Or maybe you're going, oh my gosh, this is so simple. Why are you taking so long? In which case, I will point out that if you are young enough to know how to use YouTube, congratulations. And also there's a fast forward button and a make me talk really fast and funny button. I know that. I don't know where it is, but I know it exists. So the secret numbers go on top. A goes on the bottom. This is where this method and the AC method are slightly different. Now I'm going to tell you that in this video, I'm doing this problem to set this up. There will be a second problem where I'll walk through it more smoothly, so you'll see what it looks like. This one I'm talking way too much because, you know, teachers, and they start talking, they won't stop, ever, ever. Our fun fact department meetings go for 3 days frequently. Yes, because we just won't stop talking. Okay, so I've got my two secret numbers. Remember, I found that 3 times 2 is 6, and 3 plus 2 is 5. And then I put them over A. Now, if you fuzz your eyes a little bit, you'll notice that A comes up a lot. Each of the other colors, yellow, blue, purple, green, they only come up once, but A comes up in everything. Why is that? Well, the truth of the matter is when you're talking about a trinomial, that leading term, the ax squared, and that leading coefficient, the a, is really the one that sets the tone. And that's important to know, to understand about polynomials in general, is this, the bx and the c certainly add spice, but the 3x squared, that's like the meal. This is like the condiments, or the, you know, if you put some spices on it, or you want a little ketchup, or, you know, a little gravy on something, that's this stuff. This is going to be your main meal. So this is the French fries. And we can argue about whether it's going to be ketchup or gravy, or maybe just salt, or maybe you don't like French fries at all, in which case this is a terrible example. Although, you know, French fries, how can you not love fried things? Potatoes even, so yummy. Okay, so note to self, do not make videos before breakfast. Okay, so what the heck? We've got this whole x. Now what do we do? So I'm going to copy. I know you can see the ghost of the next problem. Ooh, isn't that true with life? You can see the ghost of the problems that are coming up. You can kind of sense them ahead of time. So to recap, I have an x, and I had 3 times 2 with multiplication. I have 3 over 3. I have 2 over 3. And I have a plus and a 5. That's what my x looks like. Doesn't it look fancy? Doesn't it totally look like we could be summoning math demons? We totally can. So we've got this set up. What do we do now? Well, it turns out we did all of this work to get to these two numbers. So what we want is we want to get the 3 over 3. And we want to reduce it. But we don't want to reduce it all the way. We want to reduce it as a fraction. So what? So I can cancel the 3 and the 3, right? Let me bring out my magic pen of destiny. I can cancel the 3. 3 goes into 3 once. 3 goes into 3 once. So we reduce. So let me write this up here. We're going to reduce. And then we're going to get a new fraction. And then that fraction is going to become one of the factors. And I know you guys are very excited. And then the second step is bottoms up. Oh, you know what? I think that's an unnecessary apostrophe. I apologize. Oh no, now the grammar gods are going to be upset. Sorry about that. I will set fire to some gerunds later to try to appease them. Okay, so we've got 3 over 3. I reduced that to 1 over 1. And this becomes the worst example ever, because I know at this point you're like, wait, which is which? So when I say bottoms up, I mean that the bottom, the denominator number, comes first and sits in front of x, and the numerator comes second. So we kind of imagine this flipping this way. The bottom comes first. Now, you're looking at this going, this is a terrible example. You picked a terrible example. And yeah, the first one is terrible. But the second one, dun, 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 can I reduce it? It can't be reduced. and that's okay. So we just leave it at 2/3, and then it becomes, and let me hesitate for a moment so you can think about it. Remember, bottom is up. So the 3 comes first, and the 2 comes second. Oh my goodness, this is very exciting. So our 2 factors are going to be 1x plus 1 and 3x plus 2. And if we clean things up, we've got x plus 1 times 3x plus 2. Now, what should you always do? Well, you should always check your work. Let's check. So let's check this. I've got x plus 1 times 3x plus 2. And then I'm going to use FOIL. So it's 3x squared first, those 2. Then outer plus 2x. Then inner plus 3x. And then last, 2 times 1 is 2. And I get 3x squared plus 5x plus 2. Oh my goodness, did we get it right? Are we excited? Are you ready? Do you remember? Have you fallen asleep? Is this just auto playing and you guys have gone off to do something else? That's okay. I understand. If we had videos or anything else to do when I was in school, I probably would have been doing it. 3x squared plus 5x plus 2. Yay! The X method saved us. Thank you, X method crew. Yay! Oh my goodness. You've made it 21 minutes in, or possibly you sped it up so it happened in 5 minutes. But shall we try an example? Dum dum dum. We're going to go ahead and use this example and try to work it through in real time. Feel free to go ahead and pause the video, see if you can try it. See if it makes sense. I'll put this up here so you can kind of take a look at that. And you can always pause this and see if you can work through this on your own. Okay? I'll wait for you. Come on back when you're done. No, really, go try it, pause, and come back. Okay? Okay. I'm not kidding. Woohoo. Go ahead. I'll let this guy dance across the screen a little bit. Okay. Okay, you had your chances. Let's go ahead and see if we can do this. I am not going to use the colors. I'm just going to show you what it looks like without the colors, okay? I can always show you what it looks like with the colors in office hours. So the first thing that I'm going to do is I'm going to get my X, and possibly you might want to quickly identify your constants. So my A is 6, my B is 5, and my C is, oh, look at that, -6. Oh, this is going to be exciting. I can tell already. I'm pretty excited. So for our X, remember that up top, it's A times C. So the first times the last. So you don't have to write this. You can just look here. 6 times -6, I get -36. I'm going to roll multiplication right there. Okay. And then down in the bottom of the X, I'm just going to take the middle number, that B. So that's 5. And I'm going to remember that's going to be the one that's added. Okay. So now I need to find 2 numbers so that -36 equals those 2 numbers multiplied, and 5 equals those 2 numbers added. Okay. So as you get better at doing this, these numbers will become more obvious. But because I'm a math teacher, I'm going to go through all of the possibilities. -36 times 1. -36 plus 1 is -35. Wow. I don't know what happened there. Aliens. That didn't work. Okay. It's also equal to -18 times 2. And then I get -18 plus 2, and that's -16. That didn't work. Okay. And then -12 times 3. -12 plus 3 is -9. So what am I doing? I'm doing the multiplication to find the pairs that multiply to negative 36. And then I'm testing the addition, right? Trying to get to 5. Okay, negative 9 times 4. Negative 9 plus 4 is negative 5. And now I stop and I go, wait, negative 5? But I want positive 5. Could I multiply 9 times negative 4? 9 times negative 4 is negative 36. Yay. And then what is 9 plus a negative 4? Oh my goodness, guys, we got it. We got it. Yay. So I found my two numbers. My two numbers are 9 and negative 4. So do you remember what to do now? You take your two numbers, and those are the numbers that go on the side. So I'm going to rewrite. Oops, sorry. I'm going to do my new x. You can go back to that x, but I'm going to move it down here. I've got negative 36 on top and 5 on the bottom. Now my numbers are 9 and sorry about that. Apparently, when you set iPhones to be, quiet, it's like, but maybe you still need this alarm on. And the answer is no, thank you, iPhone. You're so helpful. So I've got 9 and negative 4. Now, could you have gotten negative 4 and 9? Yes. These two numbers can come in either order. We're going to write 9, negative 4. Now, do you remember what happens here? Let's review. We got the a times the c on top, the b on the bottom. Now, what happens on the sides? Well, the sides are going to be fractions. They have to be fractions. For this to work, they have to be fractions. So 9 over a and negative 4 over a. So we have to go back up to what was a? Woohoo. A was negative 6. Or sorry, positive 6. So we're going to come down here, and this is 6, and this is 6. Right, so those are the A's. The A's are there. The 9, I feel like one of these should be. I know I said I wasn't going to use color, but like I should ever promise that I'm not going to use color. So is this a method that's easy to learn and quick to learn? Not so much. But once you learn how to do it, it will save you some time. Because I've seen people set up this X in like 2 minutes. They just go bing, bang, boom, and they're done. And then the whole thing is factored. So I take my first fraction, 9/6, and I reduce it. So you think, okay, what goes into, take my pen of destiny. 3 goes into 9 3 times. 3 goes into 6 2 times. And I get 3 over 2. And then negative 4 over 6 is going to be what? That's what goes into 4 and 6, 2. So this becomes negative 2 and this becomes 3. I cancel out the 2's. Okay, so last step. I'm going to take my 3 over 2. I'm going to remember that it's bottoms up. The first number is the one that's on the bottom. I get 2x plus 3. And I'm going to take my second fractions, negative 2/3, and that's going to become, again, bottoms up. Start with the bottom number, 3x minus 2. And then that's my answer, 2x plus 3, 3x minus 2. Woohoo! That's my polynomial factored. Let me check. Quick and dirty. Let's just do a quick and dirty FOIL. 2x times 3x is 6x squared. Outer minus 4x. Inner plus 9x. 3 times negative 2 is negative 6. That's 6x squared plus 5x minus 6. Is that what our original polynomial was? 6x squared plus 5x minus 6. Bam! Pew, 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 pew. The X method worked. Thank you, X method gang. You're welcome. And this is, woohoo, this is what it looks like. I can't get the whole thing on screen. I'm so sorry. So is it complicated? Somewhat. Can you learn it? Absolutely. Do you have to use it? Not at all. you can be like the rest of us Luddites and just use trial and error. Trial and error will always work. It's just kind of slow and a lot of work. So is it worth learning this? Only you can know for sure. So I'm going to leave this up so you can screenshot this if you'd like it. Oh, you know what? I lied. I'm going to go one step further. For those of you who really like the AC method, there's also the AC method, which is a slightly less fancy version of the X method. Woohoo, you guys made it. Congratulations. Woohoo, yay, you're awesome. More woohoos, math on, and I guess I'll talk to you later. Bye. And -4, pardon me for just a second.